Okay, welcome to Chapter 5, Lesson 1. We start geometry, and this lesson is about lines. Our learning target or objective for this lesson is to identify relationships of angles formed by two parallel lines cut by a transversal. Okay, we have many vocabulary words this time. Okay, on our vocabulary, let's check it out. Our first word. Oh, don't want that. First word will be perpendicular lines. Two lines intersect in a plane and form right angles. Example of that would be straight line and coming straight down. Boom, and forming right angles. Board's off a little bit, but you get the idea. Line comes down and intersects and forms two right angles. Our next word, parallel lines. Two lines in the same plane and do not intersect. Try to think of examples of those. Possibly railroad tracks that keep on going forever. Do not intersect. Next word, got transversal. Transversal, a line that intersects two or more lines. And we're going to see that transversal here shortly. What we'd see here, transversal, example of that would be, we have two parallel lines. Again, sorry about that, the board is off. Imagine these are parallel lines going on forever, not touching. Transversal is going to come right across there and cut them both. So this would be our transversal right there. That's a transversal. Okay, our next word, interior angles. Angles that lie inside the parallel lines. We're going to see examples of these on the next page here. So let's go into our next one, exterior angles. Exterior angles are angles that lie outside the parallel lines. So take a look at our example I drove out there with transversal and just imagine where your exterior angles are. And once again, you can always pause the video to write down your definitions as we were moving on. And the next vocab word, alternate interior angles. Those are interior angles that lie on opposite sides of the transversal. And we'll see examples of those here shortly. So our alternate exterior angles are exterior angles that lie on the opposite sides of the transversal. And our last vocabulary word for this lesson, corresponding angles. Those angles that are in the same position on two lines in relation to the transversal. You might want to keep your vocab words handy so as we go onto the next page and we'll show examples of all these definitions that we just did. Okay, remember our objective is to identify relationships of angles formed by two parallel lines cut by a transversal. As you see on this example right here, T right here, that is our transversal as it cuts across L and M, creating our angles 1, 2, 3, 4, 5, 6, 7, and 8. Okay, first we got our vocab word of interior angles. Now take a look at our example and maybe try to jot down all of our interior angles that was formed by these two parallel lines and the transversal. Okay, pause the video, write them down on your sheet, come back to the video and see how close you were. Okay, our interior angles are going to be angles 2, angles 3, angle 7, angle 8. So you notice those are the interior there and the inside of both of the parallel lines. Everything's on the interior part. They were on the inside of the house. If you want to think of the parallel lines on the in part is the inside of the house. They're the interior angles. Okay, take a moment to pause the video and look at for the exterior angles. Okay, our exterior angles for this would be angle 1, angle 4, angle 5, and angle 6. You notice these are all on the outside of the parallel lines. They're on the outside looking in, so 1, 4, 5, and 6 are exterior angles. Now let's take a look at our definition of our alternate interior. Now there it says interior, so we know that we're going to be on inside, so we're going to be on the blue part. And alternate means they're on the opposite side of the transversal. Okay, when it says alternate, it does not mean like 7 and 2 and 3 and 8. You have to jump across. It'd be more like 8 and 2 and 3 and 7 go together. You alternate from one side of the transversal to the other. So angle 2 and angle 8 are together. Angle 3 and angle 7 are alternate interior. So take a moment to pause the video to think about the alternate exterior in relationship to the alternate interior and see how you do. Okay, on the alternate exterior, we're going to take 4 and we're going to go across the board to 6. So 4 and 6 are alternate exterior angles. And then we have 1 and we have 5. Angles 1, angles 5 are alternate exterior. So alternate from one side of the transversal to the other. And you sort of jump across it a little bit. Okay, and our last one are corresponding angles. Remember, again, these are angles that are in the same position on the two lines in relation to the transversal. So, example of this would be, I'm going to clear off some of these right here for a second so we can take a better look at our numbers. Our corresponding, let's look at 4. What do you think corresponding to 4 is on this line right here? This would be 7. So 4 and 7 are corresponding. They lie in the same spot on two different lines cut by the same transversal. Angle 7, angle 4 are corresponding. So on the other side of the flip, we have angle 1 and angle 2 are corresponding. And we have 8 is down here, so it's 5. So 5 and 8 are corresponding. And our other last two, angle 3 and angle 6 are corresponding angles. Okay, once again, if you for some reason quite not get it, you can always replay the video back and or write down any questions that you have for class the next day. Let's go on to our last example. Okay, now we're going to find missing angle measures. When two parallel lines are cut by a transversal, special angle relationships exist. If you know the measures of one of the angles, you can find the measures of all the angles. Suppose you know that measurement of angle 1 is 50 degrees. You can use to find the measures of angles 3, 4, and 8. Okay, so angle 1 here is 50. Right there's 50 degrees. With one angle measurement, we can actually find all the way through 1 through 8. Which one we work on first? we can work on what's corresponding angles we just did. What would be the corresponding for angle 1 here would be angle 2. Angle 2 is 50 degrees. That's corresponding to angle 1 and 2 are corresponding angles. Okay, now what can we do to find the measurement of our next one, or what do we want to do? Okay, one thing that's not on our vocab, but you can use angles 1 and 8. What are those called? Those are called vertical angles. They are vertical angles. And vertical angles have the same measurement. So if angle 1 is 50, angle 8 is going to be 50. Angle 2 is 50, angle 5 is going to be 50 degrees. Okay, right now we have half of our angles already measured. Now we have to do a few more. Okay, now we can go back into line L. If we think back to our lines, what's the measure of a straight line? A straight line is 180 degrees. So if we started at 1 and went all the way over to 4, that's 180 degrees. Well, if we know if angle 1 is right there, it's 50, we have to subtract, just take 180 minus 50, and that gets us 130 degrees. So angle 4 has to be 130 degrees. Now we can take angle 3, the vertical angle, what's angle 4? Angle 3 is 130 degrees. Now let's look at 4 and 7. Angle 7 is corresponding with angle 4. So angle 7 is also 130 degrees. And we could look at angle 6. We could take angle 3 and 6, which is again is corresponding, or angle 7, which is a vertical, and come up with 130 degrees. And there you have it. You can find the measurements of all 8 angles with just one angle with parallel lines cut by a transversal. Any questions? Please review the video again or write them down and bring them to class.